infinite thing.
Okay. So, okay. Yes, I'm ready. Just remove. It's not to be hot. We are too many. Okay. I think.
That's it. Yeah, it's like recording and taking.
Okay, we can go. Okay. So the title, probably the title is too much. So I tell you, don't expect really what the title is about. So just to start. So the reason for the presentation is because some months ago I got this slide from Netflix, and they say that the age of search has come to an end. So at the time I've just started my career in the search team of Euromoney. Say, my God, probably I have to get in deep with what they want exactly. What do they mean? And they see that we are now in an era that we are entering in the age of recommendation, and the difference between search and discovery is that in search people know what are looking for. Instead, in discovery is when people discover something wonderful that they didn't know before that exists. So this is what Netflix is doing, and in doing this, Netflix is really good, because I don't know how many of you are using Netflix for video, but when you go in the Netflix service, everything is personalized. So this is the homepage of Netflix. When you have a matrix, and the concept is that each row is a different genre. Could be a romantic film, could be action movie, and instead in each row you have all films that are in the same subject. And the idea is that over 75% of what people watch is coming from a recommendation. When people search for something in Netflix, just the fact that they're searching for something, it means that the recommendation hasn't worked well. So the problem is not improving the search. The problem is avoiding that people use the search. So in each row, the idea is that you want to improve the diversity, because you can have a family when there is a dad, a daughter, a mom, a son. You don't know who is actually using the system, and you want in some way to suggest something that it's correct for each one of the family member. So this is Netflix. Another really popular site is Amazon. I think probably all of you have used Amazon.
Yeah.
Yes. So what is doing Amazon? I try to open this. Let's see how it will be. So first of all,
It's a bit risky, this, if I go into your...
No. Okay. So when I don't know, Amazon. Yes, but I want to log out. First I was to log out. No, but I haven't any see, because then I show you the difference. So when you are an external user and they don't know anything about you, they show you just the popular items. And the popular items is already a good suggestion, because it's what people at most is used to buy. I don't know why I clicked there. Yes, this is then as soon as I log in, okay, this is my login, my password. This is for my nephews. It's not for me, guys. Don't. No. So I wanted to show you. If I go on the book, they start to suggest. This is me. This is a screenshot with the Photoshop. So they start to suggest books about the category that I'm familiar with, and then all the page is built about category that I can be not. It doesn't work too much well, but good enough to sell a lot of things. So you have the idea is that you have for each row different category, and is trying to sell as much as they can. So to do another part is this one, is that if I go in an item, you can see all the reviews, and then there is these things that what people frequently bought together. And this is really probably the most useful things, this part. And this is what customer also bought. So this is what the user have, but I think if I go, yes, this one. So to do that, Amazon is collecting all the view history of all the users. So I try to make a bit smaller. I don't know why I can see only one here.
That's what you just the browsing you done today.
Yes, yes, yes. But I can see, so what I've seen now, and I can work with the recommendation. So this is what I've bought recently. So I can tell, for example, if I bought a present, this is for my nephews, okay, a pirate costume. It's not for me. So I can tell, trust me. So I can tell to Amazon, don't consider this is, for example, for not for me, this is for another friend. I can tell to Amazon, please don't use this item like a recommendation, because I will never buy this again for me. I mean, that's the hope. Yes. So this is Amazon. I back to my slide. Yes. Okay. So the idea is that, so we have seen a bit how they works, and the concept is that you have your own user, and the target of a recommendation is taking all the pattern that you have from the crowd, because there is no a user that is identical to your user, but because probably no one in this room like all the type of music that I like, but probably someone like some kind of my music that I like, some other things. So the idea is just to try to extract all this pattern from the crowd and try to reflect this behavior like a mirror. So you are not like in the artificial intelligence that you want to train something. You want just to reflect the behavior. So for example, if I buy a laptop and then I buy a large screen because it's useful, and like me, there are hundreds of people that are doing the same, I can try to suggest when someone buy a laptop to do the same. So now, yes, what you want the target is the serendipities that you want to give to the final user item that he doesn't already knows, because this is the difference between this kind of recommendation and the old type, like we have in the articles of the site of Euromoney that me and Jonathan has done. This is a stupid content-based recommendation. So if you are checking an article about China prices, it suggests you all the article about the China prices, but you stay always in the same area and the same concept. If there is another things that it can be useful, because there is near to the China, there is the Japan that is collapsing, and you have to know that. We are not suggesting this because we find all the closest articles. So we try now to see, just with a small example, how all these things works. So we start with a simple example. We have just 3 users. The first is Alice, that has an apple and a puppy. Then we have Charles, that has a bicycle. And then we have Bob, that has an apple. So the question is, what else we can recommend to Bob? Probably the answer is the dog, because we know that Alice has a dog, so we can recommend to Bob a puppy. So the idea is that you have to search for all the co-occurrence about items, and if you find that someone else has bought something with some other things that your user have, you can try to suggest it. So this is the first concept. The second concept is when you have something that is really popular. This is an example that every kid in the world wants a pony. Before having a pony, everyone wants a pony. Eventually, if they then buy a pony, they change idea, but everyone wants a pony. So at this stage, we have that Alicia, Bob, and Charles have a pony. So given that Amelia is a pony, we have a case where we have a lot of co-occurrences, but we are not able to suggest anything to Amelia because the pony is everyone wants the pony, so he has no meaning for what we are doing. So we are looking for some kind of co-occurrence that are not too popular. Another example with this is the most bought things in US in the supermarkets are the banana, because they are the easiest things to eat. So most of the people, when they go in the supermarket, they buy some banana. But if you have to recommend to someone, when they enter in the supermarket, what would you like to recommend to me that I buy? I recommend you to buy the banana. It has no meaning because probably you would have already bought the banana by yourself. And given that you buy some banana, I cannot recommend to you anything because everyone is buying banana anyway. So yes, so the idea is that the pony is not a good indicator for anything. So what we want mathematically we want to do is that we want to find a way that we can understand when a co-occurrence, we have some rare items and they occur always together, and we want to catch these because when we have some rare items that are not so popular and they occur together, this is a case where really it's useful to give our recommendation. An example is, yes, this is, so the idea is that there is a mathematical concept, is called a log likelihood ratio, that is giving this, and then now we will see an example. So we will skip this. So first of all, when this is how we process all the data, we get the log. So this is the log that there is the user and the item. We have a timestamp generally. What we build is that starting with this, that can be this one, we build a matrix. We build a matrix where we lose the concept of time. Sometimes it's useful to keep the time, but in the easiest case, you can ignore it. And so here we have the concept that what each user has bought. So starting from this, if you, then we will see later how to do that. But if you make the multiplication between the translate of this matrix with the same one, you get this one. That is the co-occurrence matrix. So these things mean that in the first, these things mean that one user has both an apple and a puppy. 2 users has both an apple and a pony. 0 users has both an apple and a bicycle. So this is really the co-occurrence matrix, items per items. And the thing is that we want to find a way to understand what are the correct indicators, where are something that can be useful to recommend. So starting from this, we work building the binary matrix. So we can see the example. We have in this case on all the users, we have a total of 3 users. One has both apple and puppy. One hasn't both anything, and one has both the apple and not the puppy. So given this, we extend this to these cases that start to be a bit more realistic. So we have in the top left one case that the item A and B has been bought by 13 users, and all these users hasn't bought anything of this, and 1,000 users has bought one item and not the others. So we can understand that on average, 1 on 100 of users is used to buy the item A, and 1 on 100 of users is used to buy the item B. But the case that they both of them, it's really rare. So this is not giving you any interesting stuff. On this part, it starts to be a bit more interesting because you have just 3 cases. There is no cases where the user has both A or B without buying A2, both of them, but we have too few cases to do any conclusion. This one starts to be a bit more interesting because A and B are really rare to get both each, but they occur only when they are together. This one instead is the best because we have here 10 cases where the user has both A and B, and no cases where he hasn't both just one of these. So using this LLR, we get these numbers. And we can see that with this property, we are able to understand when something can be related to something else. So we start, given this matrix, we apply this transformation. And the only thing that stays is the relation between apple and puppy. So yes, this is our big data example. And the idea is that it has no sense to recommend the pony because what you have generally in the site, you have an area that is the popular items. And here you have to put the pony and all the things that, for example, for Christmas, you can put all the decoration for the house. But when you try to recommend something to a person, you want to find something that is useful for himself. So given that we are able to build this matrix, the idea is that how we deliver these things to the user. So we can use a search system to do that. And the idea is that at index time, not index time, offline, we can enrich each document with all the related items. So in this case, for example, the document for puppy can contain all the, I think it's, yes, it's here. We can enrich these documents with all the indicators. And so then if I search, for example, for an apple, I get all the items that can be recommended to. So this is really a simple case, and in this case there is just one kind of action, that is to buy things. In the reality, you can view article, you can view product, you can buy, you can scroll, and so Amazon is recording, as we have seen, just all the things. And so then the algorithms have to be a bit more complex, but this is just the base of how it works. This is the math behind what we have seen. So H is the history of what a user has bought, and so they are items. If you A is the matrix that is containing for each user what he has bought. If we multiply, we get the users close to the history, and if we make this transformation, we back to the items. And so this is the two kind of recommendation. The only thing that changes in these things is that in the second one, the matrix AT per A can be computed offline because it hasn't related to any history of each user. So this is the common approach, that you build offline this matrix, and then given an history of a generic user, you can suggest some items. So finally, this is the last part of the presentation. What do we have here at Euromoney? Here at Euromoney, we are using both. I don't know how long we will keep using it, but for the moment, there is both. And there is a lot of kind of action that we are storing. It's about viewing an article, add to basket, download products, view a search result, all this kind of action that are all stored in tables. That is some gigabytes of tables that we have. And so we have tried to apply this algorithm on the historical PLC store. And we are still working for the deploy, so we haven't. And about this, Elena has worked for the design. So now our site for the suggestion is really close to Amazon. We risk that they call a lawyer because we have copied exactly the same style. But I cannot show you because we haven't seen deploy. So I can just show you what I have in my local machine. This is yes, how we have computed these things. There is the log file. We have analyzed using Mahoots. So we have built the indicators and we have indexed this indicator in Elasticsearch. And so this is what we get now. That if I go in the emergency markets and book, this is a time suggestion. There's something like oil and gas contracts and foreign exchange treasury management handbooks. And this is not this. For this one, there is more things. This is about legal guide to FDI in China, and there is a negotiation about energy, annual Middle East and Africa air finance, and this is all things coming from people that has both of the items. So it's not coming from the fact that the item is similar to what we are looking for. And I think, yes, this is the end. So this is, I don't know how is the time, if I've been too fast. Speak more. I know, it's, yes, it's, so the challenge now with the recommendation is that you have to track your user. The user can change behavior. At the same time, for example, for our type of products, they have the time is important because a book of 10 years ago is not important as a book of last year, especially if it's in an area where they have the time can be critical. And so this is just a first test about this technology. If someone has some questions.
And what you've done it on, is that based just on what people have bought online? Assuming you haven't fed in stuff bought offline.
It's we are using actually all the feedback given by what people has viewed and what people has bought. And we are using in a different way because people can view things and then can buy it later. And we are using these things for now.
Does the Mahout service run all the time? Was it something you just run on a batch, or how does
it can run on a batch? The idea is that if you do it with Mahout, you can update one per day the things. Right. The only important thing is that you don't recommend something that people has bought, because sometimes happen that people, for example, buy an Xbox and then there is an offer to sell the Xbox at 20% of discount. If when you do the checkout and you push later an offer about something that he has just bought, it would be something that is not good. But you can do it offline and remove what the user has bought, if you can.
Have you ever seen the algorithm for Amazon doing price changing? It works on similar to this. I watched a documentary on it recently.
No, can you tell us?
They have an algorithm that goes through, changes the price of things thousands of times a day to increase small margins around the site. So they try and always look like they've got the cheapest product, but other linked products, so when you buy something with something else, they increase the price or change the prices of these things. That's what I've seen. So I guess your system doesn't take price or margin or anything into account. It's just
no, yes. No, I don't know about this part. I don't know about this part.
I'll try to do it.
Yes, we can do that.
I thought it's all about how we could potentially, because this is getting people to buy products, is there any way we could take a similar approach but with content? So at the moment, you mentioned earlier that the way in which you recommend content is fairly simple. Is there a way we can kind of take these kind of techniques?
Yes, the concept is the same. The concept is the same, and in the most advanced algorithm, the concept is that you about building the relation between product and product, you don't stay linked to to the exact product, but you work, you make a, we call this in machine learning a reduction of dimension, so you can understand that someone is interested on some topics, and then you can find that if he's interested in some topics, a lot of people interested on these topics are interested on other topics, and so you can just recommend of other topics that people can be interested on.
And is there a minimum? Because a lot of our sites are quite low volume, so there's not, we don't generate a lot of data. Is there a kind of, is there a rule of thumb, or?
Yes, because there is you need some about what is important is that because this is like a mirror, that the idea is that you want to, if there are some smart users, you want to give to the lastest user that has joined the site all the intelligence that has been used by all the smart users. And so as much as users you have, as much your system is able to understand this behavior. And there is some metrics that we can compare about number of items, number of users. And this is the reason why Amazon has already the best system with more users than everybody. And so we cannot, if we have to open our store, we cannot, we have any way to win with them.
So you're saying BuzzFeed, like 5 metal trades that are just going to make you go bananas.
yes, something like that. Yes.
This guy invested in Italian bonds.
Yes, don't invest in the Italian bonds.
Awesome.
I think it's all.
Thank you.
Okay.
Very much out of that track,